Good morning to all. Today we are going to start our third lesson. Our third lesson name is water exert pressure. In the previous class we already learned that water exert force. And today we are going to discuss about water exert pressure. And in this lesson we are going to explain water exert pressure which increases with the depth. Water exert pressure which increases with depth. Okay. And before starting our class, we can just explain or we can come to this topic with the help of an example. We know that the water is flowing through a pipe. For example, if we consider that when we gently press the hose pipe, okay, so that time what will happen when we at the time of flowing of water or turn on the pipe and we just gently press the tap, that mouth of the tap with the help of our finger. Okay, so when we remove the finger, so that time what will happen, that water shoots fastly or fastly and farther way. Okay, so like this fastly this water is coming out when we are gently press the tap, when it's turned on. Okay, so like that it may happen. Is it right? Yes. So which means that when we press the tap, so that time the pressure, there is an why does this water come fastly? That is because of the pressure when we are close the mouth, okay, mouth of the pipe. So that time when we are removing time, this water is coming farther and fastly. Okay, so like this it may happen. In the case of hose pipe also like this it happen. Why does it happens like that? Because that water exert and pressure. Okay, that means the force acting on an unit area is considered as pressure. What is pressure? Force acting on a unit area, that is considered as pressure. And this pressure depends two factors, that are force and the area. I already told you that the pressure means that the force exerting on a unit area is considered as pressure, and this pressure depends the force and area. How does it depends? That we can discuss. Before that, one more thing I will tell you. In your content book, here you can see one picture, and in this picture you can see the water from in means normally you can see the water we are taking in a tank, and in that tank we place two holes. You can see the two holes A, B, C like that. Then where will be the pressure most, or where is the more pressure? Where will be the more pressure? Can you say which place that more, A, B or C? If we are considering time, means according to this picture we can consider, here we are taking the water in a glass or in a container or anode. Then we put three holes. One hole here and second hole, then third one. Okay, this is A, B, C. Okay, and in which case already we discussed that water exert pressure. Okay, so in which case the maximum or more pressure it acts from which hole? A, B or C? A. Why? Because in A this water goes farther, means farther away from the tank with a more force. Okay, and at the top what will happen? This pressure decreases, like this water is coming. Okay, so we can say that depth increasing time, that means this A is at a higher depth. These parts are top level and at the bottom depth increase. When the depth increasing time, what will happen? Pressure also will increases. And the right side of that picture, you can see the case. That means the pressure increases with the depth. In the case of dam, here it is given. So pressure is more at the bottom. So water comes out with a lot of force. This proves that depth increases, water pressure also increases. So here you can see the dam and in this picture, and the surface you can see at increasing depth. And how does the pressure acting? At the lower part you can see the pressure that here it is marked with the help of an arrow. Here this diagram is like this, you can see, and that pressure that arrow marks. At the bottom, maximum pressure. Then it decreases when height is increasing time. That pressure is maximum at the bottom. So what will happen in the dams and all, that bottom surface we make more wide and strong. That is because of when the area increasing time, pressure will decreases. This we can easily say with the help of an example. You may know about the heeled sandals. Heeled sandals, high heel sandals. Okay, when we are wearing high heel sandals, normally girls or ladies are wearing high heeled sandals, and when we are walking time, we apply more pressure because that sandals, pointed heels. Okay, when this pointed heel, when we are wearing time, it exert more pressure on the ground. When we walk with this pointed heels on a mud road or a beach side, so that time for us it is more difficult for us. Why? Because each and every, when we take each and every steps, it plays holes, right? Yes. So this area increasing time, pressure will decreases, and area decreasing time, pressure will increases. So that is the dependence between pressure and area. Force increasing time, pressure will increases, and area increasing time, pressure decreases. Area increasing time, pressure decreases. Okay, and we know that if we are taking an needle, okay, and that needle, that area of that needle is very small, that are very pointed, and when this needle we placed in our hand, so that time we feel pain. Why? Because it exerts more pressure. Okay, and when we are using the chalk and we are doing like this, when we are placing, or we just doing like this, so that time what will happens? There is no pain. Why? Because that area is large. So pressure is less, so we are not feeling the pain. So pressure and the area, they are inversely proportional. That means one increasing time, other one will decreases. Are you clear? Okay, and here one more example you can see here in your content book. You already seen the case of two cases, and the pressure exerted by water in dam is much higher at the base. For that reason, walls of dams are made wider at the bottom to withstand the high pressure, and submarines also withstand high pressure when they go deep into the sea. Thus, bodies are made very strong. Okay, so that's all about our first lesson. In the first lesson, we discussed about mainly pressure, water exert pressure which increasing with the depth. That pressure increases with the depth. When the depth increasing time, if it is going up, so that depth is increasing time, pressure also will increases. Okay, and pressure is mainly depends the area. Area increasing time, pressure decreases. Area decreasing time, pressure increases. And normally in the case of dams, and we know that if we are placing water, or if we are taking water in a vessel or like this, okay, so why does this water is come out when we put the hose like this? Because water exert pressure in the walls, bottoms, and everywhere this water exerted pressure. Okay, due to that pressure only, when we put the hole, water is coming out, and that water, that pressure is maximum at the bottom, because at the bottom only, that means the bottom we can consider as it is at a high pressure, because depth increasing time, it will also, pressure also will increases. That's why the dams, the walls of dams are wide and broad. That is mainly to withstand. In dams we are holding, or in dams it holds large amount of water. Okay, so to withstand that much pressure of water, we are making its bottom was wide. That time area increases, area increasing time. Bottom wide means that walls are wide. That means area increasing time, pressure will decreases. Are you clear? So in this lesson, the basic key concept that you have to remember, pressure increases with depth, and area increasing time, pressure decreases. Area decreasing time, pressure will increases. Now we can discuss our worksheet. Now we can discuss the worksheet S3, and the first question, how is pressure related to the area in contact with it? Okay, pressure and area, that relation we already discussed. When area increasing time, pressure will decreases, and when pressure area decreasing time, pressure will increases. So like that you have to write. Second question, where will the water pressure be more and why? Here you can see two cases. Here it is given, large but shallow lake and small but deep pond. Okay, so we already learned that pressure increases with increasing depth. Okay, in this case, in the case of lake, it is 3 meter, is its depth is actually 3 meter, and in the case of that pond, its depth is 6 meter. So which one will be considered as more pressure? That is in the case of pond. Okay, why? Because the depth is 6 meter, that is more than our lake. So pressure is increasing with increasing depth. And third question, why is the body of submarines made of strong materials? That is, they are going deep into the water. Okay, so what will happen? They want, or normally they requires in the bottom, means at the bottom side, that pressure is more. Okay, so that's why we are giving the strong materials, or submarines made strong materials to withstand with a high pressure, when they go deep into the sea. Then fourth question, in which case there will be more pressure and why? Here you can see water is falling from a shower and water is coming from a tap. By looking both the diagrams, we can consider that area is more in shower and area is less in tap. So in which case, second case, there will be more pressure because that area is less, so pressure is more. Okay, so that's all about our S3. Now we can move on to our S4. That means now we can move on to our fourth lesson. Okay, now we can discuss our fourth lesson. Our fourth lesson name is Water, a Universal Solvent. Okay, and in this lesson we are going to explain why water is an universal solvent. Okay, so when we are considering time, in this whole chapter we were discussing about the properties of water. Okay, and in first lesson that we discussed like water exert force, water exert pressure, buoyant force, 3 properties we learnt. And now we are discussing another property of water. Water is an universal solvent. How can you say that water is an universal solvent? When we are considering, normally we know that we are going the beach side and all, and when we consider the sea water, okay, when we taste the sea water, that time what will be the taste? Is that taste is similar to normal water? No, some salty taste is there, right? Yes. And can you able to see the salt in the sea water? Say yes or no. Can you able to see the salt in the sea water? No, we can't able to see. Why? Because that salt is dissolved in the water, or that salt is dissolved in the sea water. Not only that, if we consider that various kinds of materials are there, and some of the materials can easily dissolve in water. For example, when we are making the tea, so that time how we are making the tea? We just boil the water, then we are adding some sugar into it, and that tea leaves also we will add into it. So that time that sugar will dissolve in the water, and tea leaves also dissolves in water, right? Yes. So that way we can consider as water as an universal solvent, because the water has an ability to dissolve various materials into it. Not only sugar and salt. How we are cleaning our house? By using some kinds of liquid like Lysols or like these things we are using. The Lysol is actually a liquid detergent, and that we are taking some drops of Lysols we will put, and we add some more water into it, then we are cleaning our house. Then how we are means cleaning our plates and all, there also some, and how and at the same time when we are using the hand wash for washing our hands, so that time also we are using the water and all. Okay, and when we are cleaning the plates and all, there also some liquid detergents in this way we can say Pril, Exo and all, Exo dishwash, like that we are seeing in advertisement and all. So all those cases we are using this water, that items or that liquid is dissolved in water. Okay, so we can say that water is an universal solvent because it can dissolve various materials into it. That's why water is considered as a universal solvent. Considering in your various cases are there, salt, sugar, lemon juice dissolves in easily in water, and how we are making the lemonade or okay, normally when we are considering that how we make the lemonade or nimbu pani and all, that is mainly we are taking the sugar and lemon, then we put some, or we are adding the water, means first or otherwise like this we are making. Okay, or you already knows that how you are making lime water and all. Okay, so that time this lemon dissolves in water, that's why we are getting the taste of lemon, that is dissolved in water, and sugar is also dissolved in water. Is it right? Yes. And at the same time we can say that water is most common solvent in our everyday life, as many substances like sugar, salt can dissolve in it. Due to this property we can say that water is an universal solvent. And at a home we make our of this property of water to clean the utensils, clothes, floors and other objects. However, there are many substances like oil, sand that do not dissolve in water. All the substances they are not dissolved in water, but many of the substances they can easily dissolve in water. So we can say that that substance is, or this water is an universal solvent. And when we are consider, if we are taking a water in a glass, okay, or anything, means normally water, then we add 1 tablespoon of salt into it. Okay, so that time we can see the salt like that. When we stir it, okay, so that time these kinds of salt we can't able to see, which means that it is dissolved in water. But when we taste this water, we feel some salty taste. That's why we can say that yes, salt is dissolved in it. Okay, and when we are making the tea, and that time we can taste, means actually for making 1 glass of tea we are adding 1 glass of water into the pan, then we are boiling, then we are adding some tablespoon of tea leaves and 1 tablespoon of sugar into it, right? Yes. And after making the tea, then you all knows the color of tea, right? Yes. And when we are drinking time, we can feel the taste of sugar and tea. Is it right? Yes. So we can say that this tea and sugar already dissolved in water. So this water can dissolve many of these substances into it. That's why when we are normally in our home, when we are cleaning time, at the time of cleaning our clothes, normally we are using some kinds of detergents powder. Okay, and that detergents powder we are adding more and more amount of water. Then only in normally how we are washing, in if we wash the clothes in a washing machine, so that time we will add some very small amount of detergents powder, but we are adding more and more water into it. So this detergents powder can easily dissolve in water. Then we can see some kinds of bubbles in it. Is it right? Yes. So now we can say that this application or this property of water actually we are using at home for washing the clothes and cleaning the house, and at the same time to clean the plates and all, we are using this property of water. Now we can discuss our worksheet S4. In worksheet S4, first question, name 5 solids and 5 liquids that can dissolve in water. Can you say the example? We can say that salt, sugar, detergent powder, right? Yes, tea leaves and coffee powder. These all dissolved in water. That all are solid objects, right? Yes. And liquids. What are the liquids can dissolve in water? Milk, alcohol. Okay. And when we are considering about the case of and at the same time some liquid detergents are there. Like Lysols, already I told you that. And the liquid detergents like Lysols, Exo, like this you can add. Then second question, how does the property of water as an universal solvent help us in? First one, cleaning clothes, and B, making tea. And when we are cleaning clothes, how does the property of water as a universal solvent is help us? That when we are cleaning the clothes, we are using a detergent powder, and that detergent powder can dissolve in water, then we can wash our clothes easily. And making tea, when we are making tea, this tea leaves can dissolve in water, and the sugar can also dissolve in water, so we can easily make the tea. Then third question, carbon dioxide dissolve easily in water. How is it useful for us? And one more thing you have to remember, not only these solids or liquids can dissolve in water. We know that 3 states of matter, that are solids, liquids and gases. Gases can also dissolve in water. How can we say like that? In water there is dissolved oxygen and carbon dioxide are there, and dissolved oxygen is used by the fishes, aquatic animals and plants for their breathing, and dissolved carbon dioxide used by the plants which is living in water for the making of their food. Okay, so carbon dioxide dissolves easily in water. How is it useful for us? It is useful for the plants to make the food. Are you clear? So that's all about today's class, and today's class we were discussing about the two new properties of water, that are water exert pressure and water as an universal solvent. So what are the keywords that we discussed in this lesson? In these two lessons together we can write. In the first lesson we learn force, area, depth and pressure, right? Yes. And in the second lesson we learn universal solvent. Okay, so water as an universal solvent. Why water is termed as an universal solvent? Because it can dissolve many of the substances into it, liquid, solids and gaseous substance. But some of the substances can't able to dissolve in water. And it increases. When depth is increasing time, what will happen? Pressure also will increases. And what is pressure? Force acting on an unit area of the object is considered as pressure. Okay, so that's all about our class. Thank you and have a nice day.